This video will demonstrate how to extract a topo surface from a Revit model and create a laser cuttable DXF file similar to this to represent the different contour intervals on your model that could be then cut out and glued together in sequence, kind of like a 3D printed model of your topo surface or topography for your physical model as part of marking period 4 project. So to jump right into it, here's a sample house with a topo surface. First thing I want to do is isolate the topo surface so I don't see any other elements such as trees, walls, and roofs. So I select the topo surface by clicking on it once, and I come down here to the glasses button. I'm going to select isolate element. Now it's isolated on its own. Next thing I did is I went to the site plan and I measured the size of this topo surface so that I know the real world size of it. I went to a top view in site plan, so I double clicked site plan under floor plans, and then I went to the modify menu and clicked on the ruler, and then clicked on the 2 points across and see that it's about 200 feet long. Now I know the size, the real world size of my model. Let's continue with the prior step. So write that down somewhere so you know how big it is. Yours might be different, but I measured the biggest dimension of mine, which was about 200 feet. My next step is to export this. So once I have the model selected and isolated, like I just showed you before, click on the File button from Revit, Export, CAD formats. We're going to select an OBJ file. That's an object file, similar to if you were 3D print something. They ask you for a resolution. Medium is fine. I would use feet and inches as the default measurement. Hit save. Now, the save window pops up, so now you need to pay attention to where you're saving this. I suggest, like always, save on Google Drive. I've already saved it, so I'm going to skip that step. So once you've exported the file, you need to go to a new program that we haven't used before called Slicer. So in your start menu, you should find a program called Slicer for Fusion 360. So you can go ahead and open that, which I already have open here, and then you can go ahead and import your model. So you would select File, Import, or Open, which I already have, so I'm going to skip that step and just looking for the OBJ file. Again, pay attention to where you saved it. I put mine in my documents, but I would encourage you to use Google Drive. Once you've imported it, you can view your surface, right-click, hold the right mouse button, and move your mouse around, and you can see your surface. Now we need to set up the parameters for exporting this to create the 2D patterns like I showed you earlier for AutoCAD. There's a number of steps. First thing is you want to, if you click on this manufacturer settings button here, this brings up some windows on the bottom here, some options on the bottom. So first thing you want to do is think of your material size. So the material represents what are you actually going to cut this from, such as plywood, cardboard, maybe plastic, etc. So you need to know the size of that material so you can measure that with a tape measure or ruler. I just picked 4-foot square, which is 48 by 48. And then the thickness is super important. Ideally, the thickness will match these different intervals of your model. So the steeper your model is, such as if you're modeling a cliff, you may need a lot more, a thicker material versus something that has a very low slope to it. You would need maybe a thinner material in order to actually see that slope. In other words, if you have a very gradual, you have a topo surface that does not have a lot of elevation change, if you want to show that it's a topo surface and not just a flat surface, you're going to need some thinner material, maybe even paper, to glue on top of each other in order to get these different layers to show. So that's what those boxes are for down here. These last two you could ignore. Next thing is the object size, so the actual model. So these numbers here are in inches. When I brought this in, this was my actual size. So this said 200 and something before. So I scaled it down to my actual model size. So what I did is I just typed in the actual maximum length here. And the way I figured that out, I simply took my Go to a calculator here. My model was 200 feet long. If I multiply that by 12, that becomes 2,400. So that's the real world size, 2,400 inches. That's obviously way too big to model for our purposes, so we're going to have to pick one of the standard architect scales. If I wanted to make this 1/4 inch equals a foot, if I divide this by 48, that means my base of my model will be 50 inches, which is still pretty big. That's almost 4 feet. So let's clear that and go back to 2,400 and divide it by 96. This would be 25 inches. So that would be equivalent to 3/16 of an inch equals a foot. Still okay, kind of big. Or if I went to divided by 128, this would be 1/8 inch equals a foot scale, because 12 times 8 is 128. That would be 18.75. So these are the different options for how big the model would actually be. So I picked 3/16 of an inch equals a foot, which gave me my overall length of about 25 inches. So I just changed the length to 25, and the height and width automatically adjusted because I have the uniform scale option checked off. Okay, so once your size is determined, this is probably one of the most important pieces, because if it's way too big, you're going to have a ton of slices, or it just won't be manageable to make. Now you have to change the slice direction. This is a little confusing, because by default, it slices. I set this back to 0, this is to 90. You can see now it has vertical slices here. And if you look at the preview here, it's a lot of slices. You're slicing through it vertically here. So instead, if I rotate this back to 0, you select the ring that you want to rotate on, and usually rotate it by 90, you can see that in my preview now these slices actually make sense. So you can see the preview of how many slices I have here based upon the settings I have here for my material size. If I were to make this 24 inches, for example, you see now my page size, material size changed, and I need more materials. So you can play around with that, see your teacher for help on that as needed. Now, once I've confirmed all these things are correct, I'm going to hit Get Plans. Under the Get Plans, this shows you the same preview you saw before. I'm going to select File Type Export as DXF. I'm going to leave it in inches and export to my computer. Again, this is another file. This comes out as a zip file, which is a compressed file. So I exported mine, and I have this slicer folder here that I created under my Documents folder. Once that folder is created, I went to that inside that folder, open it up. There were 2 files in here. I copied them, Control-C, and then pasted them outside of the folder to unzip them. Now I have 2 AutoCAD files. Each of them represents the different pages. So if I opened up Slicer 1 file here, I bring AutoCAD into view, you can see now I have the DXF that I could then export to RG LaserWorks to laser cut these different profiles out. And there's 1 file for each of the different pages that was created. And that's a wrap. Thank you for watching.